Hello friends, I welcome you all to this brand new series on C programming. But here what I'll be doing is I will not be teaching you syntax in Prairie. So I'll be teaching you the way I have learned this programming language. That is, I have learned this programming language by solving problems. And whenever required, then I refer to book that what this particular syntax says or how to apply this particular logic in a program. So with minimal amount of syntax, how can I write a program? That I will teach you. So first what we'll be doing is we will be solving some introductory problem. That let's say I'm interested in writing a program in Python that will print your favorite subject in engineering. Then how will you do it? So first thing first, the very basic thing which you should remember is whenever you are having a program, let's say this is my program. So at the beginning of my program, I'm using some header file. And is not working. So header file. What are these header files? Why are they called? They are called as header file because if you look any page, so these are the portion which we called as headers and footers. So this is header and this is footer. So the files which we place on the header section of the page of your program, that are called as header file. What are the purpose? The purpose is very simple. They are nothing but the bundles where some functions are already kept for you. And the basic header files which we will be using are two. First is stdio.h and another one is math.h. Stdio means standard input output. So whenever I have to write something or transfer some data from the keyboard to the program, then I will be using this because there is a function called as scanf. Whenever I have to print something on the console, then I will be using it with the help of print. So there are two functions. One is printf, another one is scanf. So these two functions are called as, this one is called as output function and this one is called as input function, because this transfers the data from the keyboard to the program, and this particular function, sorry, where it has gone, this particular function displays the data or the output to the on the console. That's it. So let's say I am interested in writing this program. It has to print something onto your terminal. So we will be using printf. Now, apart from this, there is your main program, that is the entry point of your program. Then inside main, your work will start. So whatsoever you have to do, you will be writing here. Now, any function should return something. Not should, but normally it returns something. So you should be mentioning the return type of this function also. So in general, the return type of function comes, then the name of the function, then the parenthesis where you will be passing some argument, then this is the block. This one is the block of your function, which will tell that this is my region of influence. That's it. And then the return type, return based on this return type, what you want to return from this particular function. In general, when this function successfully return, we want to display something onto the screen. So let's say I say 10. Whenever it successfully run, then just display 10. That's it. This is all our program. And if you understand this, done. Nothing else is required. So directly head to the editor. So I will be using code blocks for this. Open one page, empty file, save it. Let's say it is first.c. Then the first thing is header file hash include stdio.h, and then the main function. Now the thing is, this is the block of main function. Okay, then I have to write int, not I have to write, let's say I want to write. So as I'm saying, it will be returning something integer. So let's say 10 it will be returning. Doesn't matter. Now, the program, the question was, what is the question? This was the question. Write a program to print your favorite subject in engineering. I just have to print. What I have to use? I just have to use that printf. That's it. Printf means print formatted string. So let's say my favorite subject is maths. Okay, then after any statement you should be placing this semicolon. This is tell you that this is the end of this statement, end of this line. Always, if this is not there, then it will throw an error. Okay, now if I run this, what I should get? My favorite subject is maths. So it is saying my favorite subject is maths. Apart from this, you also look this return 10. What is return? 10 when the program or the main function successfully runs. That's it. Congratulations. Now you know how to write or print a string onto the console. Anything written in double quotes is called as a string. So printf, then parenthesis, and then inside you pass a string. That's it. You have done. Congratulations. This is your first program. Write a program to print your favorite subject in English. Engineering, you have done it. Now the next task is to write a program to convert Fahrenheit temperature to degree Celsius. Now how this is done? You know, whenever you have anything in degrees Celsius, let's say 20, then you can convert it into Fahrenheit. Or if anything is given in Fahrenheit, let's say 90, then you can convert into degree Celsius. So what is the question? The question is basically to convert Fahrenheit temperature to Celsius. Okay. Now, degree Celsius is 5 by 9 times degree Fahrenheit minus 32. This is the formula. Okay. Now remember that this is what we call as an expression. And whenever we are having plus, minus, division, multiplication, everything, they are called as arithmetic operators. So operators always works on operand. So these will be, this is a constant operand, this is a variable operand. What are variables? Variables are basically names given to the memory locations where we keep the data inside our system. So if this is the memory location, so I will be calling it as C. So that will be holding degree Celsius data. And if this is the memory location, let's say this I will be calling F. So this will be holding degree Fahrenheit data. That's it. Simple. Then inside any program or inside the main function, you require three things. Remember, first is input data, then procedure or the steps you have to perform, and then output. Okay, so here what is my input data? It is temperature in degree Fahrenheit. What is the procedure? This equation. What is the output? It is nothing but degree Celsius. So in any program we have to follow this. Now how the data is saved? That is depending on the type of that data. So primitive data types in C we will be using normally integer, float and character. Integer means integer value, minus 10, 10, 2, 9. Float means with decimal 2.9, 15.5, minus 29.27 and so on. Char mean any character, let's say A. A is a character. And let's say comma is also a character. B is a character and so on, all the characters. So this is what we call as the data type. This is primitive data type, not all but essential one. So we should be having some input data, and before we give any data we have to tell its data type. This is normally followed. So variables have to be there in any program. So variables are there to hold the data or to refer to that memory location where you want to save the data in system. That's it. This is what you should understand. So whenever I have to write any program, the first thing is I should be declaring variable. So in this program, I am having two variables C and F. Why? Because one is input variable, another one is output variable. What is input variable? This is Fahrenheit. And what is output variable? This, that is Celsius. Okay. Now what? Once this is known, now let me tell you where this data is sitting. So if I write printf and then percentage D or percentage U and then add the address of C. What does this mean? Now I am printing a string, but why this thing? Basically, what string I want to print? I want to print the address of C, and this M% is telling you that this is the address of what variable? C. And what is this percentage? Whenever I have to write something inside the string, especially the variable, their values, and so on, then I have to tell in priori that what is the format in which I have to print that particular thing in the string. So this is just the format of that particular data. Whenever I want some integer, so I will be writing D, percentage D. Whenever I want some float, I will be writing percentage F. For unsigned integer, without any sign, I will be writing percentage U. For character, it is percentage C, and so on. So here, what it will give? It will take the address of C and print it. That's it. So if you run it, you see the address of C is 64222092. Apart from this, if you want to print the address of F where the F variable is pointing, then this should be F. Okay, I have done this. Now the question is, have I done it correctly? Though I have done it correctly, syntax is perfect, but there is a problem. The problem is, let me run it, then I'll show you. So the problem is this. Suddenly the address has become large. Why? No, the address has not become large. It is basically C and this is basically for F and the first one is for C. So to do this, what happens? In C, the printf statement doesn't bring the cursor to the next line. We have to ask how to do it with the help of escape sequences, that is \n. This is a new line character. This one is a new line character which will instruct that come to the next line, come to the new line. So if I run this, so you will be able to see that first C address is printed, then come to next line, and then F address is printed. That is, the address of F is printed. Now, what is required? The thing is, I have to give value of C to the program. So, how can I give? There are two ways. First is, you initialize the value of C here itself, like this. This is one way. But this is not a general approach. The general approach is that you should make your program such that the user should be in a position to transfer data from the keyboard to the program. How can we do this? Very simple. What you do is, you first pass a string, because if you don't pass a string, then it will be very difficult for the user to interpret that what he should be typing. So enter temperature in degree Fahrenheit. Okay, now how to transfer? This is just the statement which will be printed on the console. So to transfer data from the keyboard to the program, you should be using scanf function. This is scan formatted string. Yes, you have guessed it right, because I have used double quotes there for string. So inside this, we will be using the format specifier for that variable which I want to transfer from the keyboard. So what I want F, and what is the data type of F? It is float. So I have to use percentage F, and then comma, and then the variable name, that is F. But what F? Where I have to transfer this? At the address of F. Don't forget to write this %. So now this program is capable of taking the data from the keyboard and transferring it to the memory location of that point where F is pointing. Simple. Close it. Done. If you run this program, what it will say? Enter temperature in degree Fahrenheit. Let's say I am entering 90. Done. Return 10, because that is what I have asked this program to do till this point. So this is my data part, and that is over. Now comes my procedure part. What I know, that degree Celsius is 5 by 9 times that F minus 32. Now this is what I have done. I have written an expression. I have written an expression, and this is not equal. Remember, this is called as assignment operator. What it is doing? It is taking this, solving this, and then transferring the value to the variable C. And what will happen? This data will be transferred to that memory location where C is pointing. Now this part is over. Is there any mistake? Syntactically it is correct, but logically there is an error. What is an error? We will see it later on once we run this code. Now, I said na, in any program there are three parts: input data, procedure, and output. So, input data, okay, what is procedure? This is procedure. What is output? Now, look, for output means you have to use printf so that you can transfer the output onto the console. So percentage f, why f? Because we want what? C to be transferred. So that's why we are writing percentage f, because the format of C is float. So if I run this program, what do you think? Will I be getting any answer? No, because I will always be getting 0. You know why? Let me tell you why. Let me run this program and then I'll show you why. So if I run this program, it is asking for degree Fahrenheit. So if I give 32, let's say, or bigger number, let's say 100, so it is returning me 0. That is what I have predicted. But the question is why? Because of this expression. Friends, remember, whenever you are dividing integer by integer, the output will always be integer. What is 5? Integer. What is 9? Integer. If you divide 5 from 9, you should get 0.556, but 0.556. And this division will always return what? Integer only. So 0.556 will be converted into integer. So 0.556 will be removed. So 0 will come. So that's why you are multiplying this expression by 0. This is 0. So you are getting wrong answer. How to handle this problem? What you can do is you can convert this 5 to 5.0. So if you do this, so you are now converting the data type of this constant, which was previously 5, to float. Previously it was integer, now it is float. Now if you run this program, let's say 100, now you will be getting 37.77. There is another way of typecasting a variable. That is, you can write float like this. So what will happen? This constant now has been typecasted to float. So if you run this, let's say 100, so now you are getting the same thing. So that is how you can typecast any constant. And if this will be, this would have been a variable, then variable also. Variables are what? Those particular names which hold data. Okay. So that's it. Done with the program. Now you have prepared this program also. That is, write a program to convert Fahrenheit to Celsius. Now you have converted it. So it is so simple to write program, and with little amount of syntactical information you can do wonders. You can write any program. Let's take another. Write a program to read a circle radius and computes its area, perimeter, centroid, and moment of inertia. So let us write a program to find out the area and perimeter only. Let's say. So for that, what is required? So if you think of a circle, now this is a circle, this is the radius. So area is nothing but pi r square, and perimeter, that is circumference, is 2 pi r. Now what is the input variable? You guessed it right. It has to be radius. Let's say I am giving radius as 1. Then this is input. Now this is my procedure, and then finally I have to print area and perimeter. Okay, so this is my program. Now let us write this. So first I have to have variables. So radius, area, perimeter. Anything else I require? Yes, pi. Okay. Now what I will do, I will initialize pi with 3.14. You all know this. Then I have to pass radius. So let us ask the user to enter. So printf enter radius. Then close the statement. Then scanf. Then what is the data type of radius? It is float. So at the address of R. So at the address of R, transfer this data. So this is all over for the data part. Now what is required? I require area. But can I write it like this? No. Whatever variable I am writing, I have to tell in priority its data type. Because the moment I tell the data type, what happens? A memory location is created where I will be storing it. So if I don't create memory location, if I don't reserve memory location in primary, then where will that particular result go? So remember, I have to create area perimeter as well. Though I have created, yes, oh sorry, I have already created, but with a different sense. You look here, it is small a, it is capital A. For C, it is different. Why? Because C is a case sensitive language. Capital A, small a, capital B, small b, everything they are different. So the area is nothing but pi into, this is into r square. Can I write like this? No, this is bitwise operator. I cannot write. Can I write like this? Yes, you are very well permitted to do this. Will I be doing this? No. What I will be using a function called as power. So r raised to the power 2. That is how I will be using. So pi into r square. So before that, you should know where this power function is residing. This power function is residing inside the math module. So you should have that math module with you. So now I will be printing perimeter PERI, that is 2 pi r. Once I have done this, so my procedure or instruction part is also over. What I have to do now? I have to print. So printf, I will be writing like this. Area is whatsoever I will be writing format specifier, that value will come here. So let's say percentage f and then perimeter percentage f. So then comma, the first f is for area, so I will be writing area first, and the second f is for perimeter, so I will be writing perimeter. Done. It's over. So if you run this, then what is the radius? Let's say I'm taking 1 as radius. So my answer is 3.14 is my area and perimeter is 6.28. That's it. It is so simple. Okay, so now you know that how to declare variable, how to initialize them, how to transfer data from the keyboard to the program, how to write your expressions, how to print the output. And at the same time, you also have seen this math module, because this power function is there in math module, log is there in math module, sine, cos, tan are there in math module, square root is there in math module. So many math functions are there, and as engineers we can use them. Okay, now let us head to next problem. The capillary rise in a capillary of diameter d is given by 4 sigma cos theta by rho g d. Okay, then rho is 1000, sigma is 0.01, d is 0.01, g is this, and theta is this. Let me copy this and bring to the program. So what is the program? This is the program. Here I will delete everything. I will start a fresh float and let me print here. So the first variable for me is h. So h, then theta. So I cannot write this symbol theta. Then what? Then rho, I cannot write this symbol, so I will be using RHO. Then this sigma, so I have to write sigma. Then D, I have to write D. Then G, and what else is missing? Theta is already there. So this part is over. Okay. Now what is required? H is required, so H is already there. Okay. This statement is over. Now I have to transfer data from the keyboard, but before that there are some standard things which you can initialize. For example, rho density, you can say it is 1000. Then what? Sigma. What is sigma? It is 0.01. Okay. Now what is G? Again a constant value 9.81. So all should be written in correct syntax, that is close the statement. Once this is done, now I can ask for theta, that is angle, as well as what? D, diameter. So I can give a statement here, printf enter theta and that's it. What it will do, it will come to the next line and then start asking for the input data. Then I have to transfer it from keyboard. So what is the first one which I have to transfer? Theta. So percentage f, then give space. Then what is the second thing? Diameter. So percentage f again. So here I will be writing at the address of first one is theta, and then the second one is diameter. Okay, then close it. So this part is also over. Okay, so let's, what is given in the program question. So theta I have to take 0 and d as 0.01. Okay, so what is so theta is 0. So let us so after this, once I know this, I have to use that expression to transfer. So input part is over. Now procedure, h is 4 times sigma times cos of theta now bring this in one bundle, then use divide, and then 4 sigma cos theta by rho into G into D. That's it, done. Your H has come now. Now finally you have to print it, H. Now if I ask you, is there anything I have to do more? Yes, there is a thing, but you should feel it first, then I'll understand, when I'll make you understand that what mistakes I have done in the program. Can you tell in Priory, just by looking this particular program, what mistakes I have done? Yes. The first is at the address of theta. So here it should be at the address of D. What is the second mistake? The second mistake, friends, is though I have written theta, but always remember that angle is always in radian, not in degree. So what I have to do, theta, assign theta times pi by 180. So you also require this pi. So instead of creating new variable, let's say 3.14, you write here itself. Then what? Once this is done, what you can do is you can run the program. So if you run it, it will say enter theta. Let's say theta is 0 was given, let me take 10. Then the second one is the diameter, so 0.01. So the H will come out as 0.000402 meter. Why this is coming so less? Just because of the diameter. So if diameter is less, then the capillary rise will be more. So you can check it. So let's say angle is 0, and the theta and the d diameter is 0.001, let's say. So if you run it, it will come as 0.004 meter. So it is now a bigger height in comparison to the previous one. So in this way, you can create your simple programs. Remember, in the program, first should be the input, then the procedure, and then the output. That's it. Now let's see what is left. Is there anything left? No, nothing is left. So friends, in this introductory lecture, I have told you that how to write simple programs, how to do simple calculations using your expressions, how to write expressions, how to use printf and scanf, print formatted and scan formatted strings, for displaying data and for taking data from the keyboard, and how to write a program. So you have seen that how I have written every program. I have used minimum amount of syntax, and I have implemented maximum amount of my knowledge of mathematics to solve this. So in the coming lectures also, what we will be doing is we will be taking problems and then solving them, and in between whatever syntax will be required, we will be learning it there itself. So in this lecture, till this point only. In the next lecture, we will be learning more. Thank you.